Welcome back, students. Today we're going to be talking about the transformations of linear and absolute value functions. We're going to be going through several different types of transformations and how they look when dealing with either linear or an absolute value function. So, to start off with, we're going to do horizontal translations and vertical translations. Translation is just a shift, a movement to the left or right in horizontal, up and down with vertical. Now, one key thing to notice is the equation that they give. So y is equal to, rather than just f of x minus h. And it tells us that this would create a horizontal translation of the graph of f of x. Now, by doing this, they also give us this image that if I have f of x minus h, and h is less than 0, meaning h is a negative number, so minusing a negative, then this will move us to the left. However, if we minus some positive number, that's going to move us to the right. That's a bit wordy right now. We're going to see what that looks like a little bit later on, but just know that, and I think the key thing to pay attention to here is the way that the transformation h, that h is inside, is a number that we've added or subtracted to x inside of the function. It is part of the change in the input of the function. Whereas with vertical translations over here, where we're now going to use k, but notice once again, we're just adding or subtracting. We're either adding, I guess I should say, adding a positive or adding a negative, which is just going to look like add or subtract. Now in doing that, that's going to move it up and down, but notice how k is not part of the input. It is not inside the parentheses. That's what's going to make the difference between adding and subtracting that creates a horizontal translation and one that creates a vertical translation. All right, so let's see what that actually looks like. We've got f of x is equal to 3x plus 1. We want to write a function g whose graph is a translation 4 units down of the graph of f. So we are going to take, let's say, y is equal to f of, now we want to go up and down, and so we are going to use this vertical translation. So f of x and 4 units down, so k would be a minus 4. All right, so now let's simplify that. Y is equal to, I'm going to replace f of x with what f of x is equal to. So a 3x plus 1, that minus 4 is there. And now let's simplify. 1 minus 4 is a negative 3. All right, let's quickly take a look at what that looks like graphically to make sure that that worked. So I'm going to pop over here to Desmos, and let's go ahead and create our 3x plus 1. In fact, it'd be easier if I had this. Okay, so there's our 3x plus 1, and we said it was 3x minus 3. Okay, so let's see. Did we shift it down 4 places? So here was our red one. So we go down. So notice how that's at 2. So this one's at 1. So down 1, 2, 3, 4. Yeah, it's down 4 places everywhere. Okay. And in fact, if we set up some variable, let's do a equals 2. Great. Now I'm going to take this and I'm going to replace that with A. So notice what's happening. As we do this, it moves our line up and down in accordance with whatever A is. All right, so back to this. We've still got our f of x. This one wants us to go 5 units to the left, so that's a horizontal translation. So we're going to have y is equal to f of. Now to make it go to the left, then h would be a negative number and we minus it. Now minusing a negative is just adding it. So I'm going to have x plus 5. Okay, according to that graph, we're doing x minus negative 5, which would just simplify to f of x plus 5. So what does that look like? What we are doing now is changing the actual input for x. So where this used to be f of x is equal to 3x plus 1, which tells us to take any input x, multiply it by 3, and add a 1. Now the input wasn't just x, but an x plus 5. Regardless, we take the whole input, we multiply it by 3, and add a 1, which is going to simplify to 3x plus 16. Okay, and that is going to create 5 units to the left this time. All right, so now that we've done that, let's look at reflections and how reflections are done. Notice the difference in the equations. Once again, it's that difference between, is this negative going to be inside the input parentheses or outside of it? Okay, if it is outside, if it is in front of the function itself, this is going to create a reflection in the y-axis. We are changing all of the y values that were positive to negatives and all the y values that were negatives to positive. That's just going to switch everything over the x-axis. However, when we change our inputs, all of our positive inputs would now be negative inputs, and our negative inputs would be positive inputs. That's going to switch where we are in between the y-axis. So this creates the reflection in the y-axis. All right, and now we've got a nice example using some absolute values. First one, we're going to create across the x-axis. So to go across the x-axis, we have the negative in front of the function. So that is a y is equal to negative f of x, which would be a negative. Now we need to input f of x, x plus 2 plus 3. So we've got two things there. Both of them are going to need to receive that negative. So this becomes a negative absolute value of x plus 2. Oops. Minus 3. Okay. All right. Now let's look at B. This time they want a reflection across the y-axis. So y is going to be equal to f of negative x. So we are changing the input to a negative x. So we're going to take absolute value. Here's where x used to be. So we're going to change it to a negative x. And then everything else can stay the same. And there we go. There's our function. Okay. To see that in action, well, you can always go back to Desmos and graph both of them to see if you successfully achieved it. As you are working, I hope you do use Desmos a lot to check whether or not you did the translation or reflection or any other transformation that you thought you were doing. All right, horizontal stretches and shrinks. So previously, we've talked about vertical stretches and shrinks. Today, we're going to also include horizontal stretches and shrinks. Notice once again what it is that causes that difference between a horizontal or a vertical, across x-axis or y-axis. Okay, and once again, is the number causing the transformation changing the actual input, or is it changing the output? Okay, and that's what makes that difference. So if we are multiplying our input x by an a inside of the input, that's going to create a horizontal stretch and shrink. A special thing to pay attention to is by a factor of 1 over a. So it doesn't stretch or shrink by a factor of a, it stretches and shrinks it by a factor of 1 over a. Okay. Now, if this is also useful, if a is greater than 1, notice it created a horizontal shrink. Things moved inwards. Whereas when a was some number between 0 and 1, that moved it outwards. So it created a horizontal stretch. Okay. Conversely, here we got vertical stretches and shrinks. When we multiply the output, the function itself, by a number greater than 1, that vertically stretches it. When we multiply by a number between 0 and 1, that vertically shrinks it. Another thing to notice about these graphs, look, they're pretty much identical, only the arrows have changed. These can look very similar. A horizontal shrink is the same as a vertical stretch. However, it is in the equation itself and how it was done that we can identify the exact amounts of by a factor of what. Okay, but any vertical stretch could be associated with a horizontal shrink. But it would not always be clear unless we were looking at the actual equation of by what factor. Okay, so let's look at this one, writing stretches and shrinks of functions. So we've got f of x is equal to the absolute value of x minus 3 minus 5. We want to write a function g whose graph is a horizontal shrink of the graph by a factor of 1/3. All right, so let's start with a, and we'll just complete that first. So there's a few things to unpack. Horizontal shrink first. So we know we're doing something to the input. We now need to figure out what a is. So they told us that it was by a factor of 1/3. Remember, horizontal happens by a factor of 1 over a. So a is not 1/3. A is actually the 3 because it's 1 over a. So this is going to be f of 3x. Okay, so now we can substitute that into our equation. So f of x was equal to the absolute value of x gets replaced with 3x minus 3. So wherever the x was in the equation, replace it with whatever your input is. Then minus 5. And there you have it. All right, now let's look at b. So and I guess we were supposed to have called this g. So this is going to be g of x There. So now g of x is equal to absolute value of 3x minus 3 minus 5. All right, let's look at b. A function h, put that down right now so I don't forget it this time, whose graph is a vertical stretch, meaning we're doing something to the function f of x. We are multiplying by the output rather than the input of the graph by a factor of 2. Now in this case, a is what we do a factor of. Okay, vertical stretch by a factor of a. So we are doing it by a factor of 2, so this is going to be 2 times f of x. All right, well, let's replace f of x. Let's substitute it in. So that's going to be absolute value of x minus 3 minus 5. This multiplication of 2, we need to multiply it through to both terms. So 2 absolute value x minus 3 minus 10. All right, and we've created a vertical stretch of the graph by a factor of 2. I hope this helps. Good luck on your assignment.